I'm very happy to introduce you to Rob Levy. He's a staff engineer at Lightning AI, a New York City-based startup. At Lightning AI, the team is focused on defining the next generation development and deployment pipeline for other AI and machine learning operators. Specifically, Rob's work focuses on data ingress and egress needs of applied models and the optimization of model deployments. Let's welcome Rob for the presentation.
Perfect. This seems on. Thanks so much for coming out. My name is Rob. I'm a staff engineer at Lightning AI. I'm going to talk to you all today about LLM evaluation and deployment on the cloud. I know people might be at different, various levels. Some of us are PhD researchers, some of us are more towards the MLOps side or the management side. So I'm going to really try to cover two things in the next 30 minutes. First, what is Lightning AI? What do we do? How can you get started with this today, even if you're just a hobbyist? And how can we help you accelerate deploying LLMs? And then second, how can we save your enterprise real time and money at the scale of hundreds of thousands of dollars if you are bringing us some of the harder problems that we've seen other enterprises approach us with over the past few months? So, as we all know, being in this wonderful industry, iteration speed is king. All of the tools that we use on a daily basis, they are just fantastic, and they always work without any hiccups or bumps in the road. I wish this were true. Unfortunately, it's not. There's a dichotomy that has emerged in our industry where the statisticians, mathematicians, scientists who are typically designing models or fine-tuning experiments and running those experiments, they need to learn a lot about the orchestration and the infrastructure in order to get those experiments to scale to a production use case. But those are two very different types of people that have that knowledge. On one side, you have PhD level researchers who you want running these experiments. On the other, you have orchestration specialists, engineers, platform people. So this was realized by our founder about 5 years ago, and we created PyTorch Lightning as a response. If you've ever done a fine-tuning or a training using PyTorch, you may have run into the issue that it does not scale very well when you go from single GPU to multi-GPU. In order to go from one to multi, you need to do a lot of configuration that ultimately is again a waste of your talents if you are one of those people who is designing experiments and models. So PyTorch Lightning abstracts away the scalability so that if it runs on one GPU, it will run on tens of thousands. And the community gave it a great response, but we got a response back from a number of researchers and academics who said, hey, I've been using PyTorch for years. I spent years mastering these configurations. I want that low level of control. So we had to develop a second library, Lightning Fabric, to give it back to those people. It comes packaged with PyTorch Lightning, and so with PyTorch Lightning, you know your PyTorch code is scalable. With Lightning Fabric, you get the same level of ingrained control as if you built all of the orchestration with PyTorch natively, but it's in a much more readable configuration. Over the years, we've added 5 more libraries. Earlier this year, in partnership with NVIDIA, we launched Lightning Thunder, which is a PyTorch to PyTorch compiler for optimizing your model code on NVIDIA GPUs. We've also dipped our toe into the experimentation and the metrics side of things by releasing Torch Metrics, and turned our attention recently towards inference and serving of models. We have LitServe, which is our generalizable serving model, but we recommend using this if you're going to serve a text or vision model. And specifically for LLMs, we've extended that library and made some optimizations and rolled it out as LitGPT, which is actually going to be part of my demo in a few minutes. Last, in the open source library that we have LitData, which is a distributed data streaming library. Its job is to take data from a cloud source, an S3 or GCP or Azure Ops bucket, automatically chunk it, and stream those chunks into multiple GPUs. So using LitData alongside PyTorch Lightning and Lightning Fabric, you can easily scale your single GPU jobs to as many GPUs as you require for that task. Now, while we were developing these libraries, we realized that this problem isn't just at the library level. It actually exists at the platform level. If you look at developing an enterprise MLOps pipeline, you typically have a spectrum that looks something like this. On one end, you have AWS Glue or Databricks, but you have your ETL needs. You need to take your data, large amounts of it typically, and transform it. Then you have, in the middle, the development platform. You need some way for your engineers to interact together and develop on that data and create these models. And so you have the Colabs, the Azure Ops, and the SageMakers of the world. And then you have the experimentation plugins, like weights and biases, that you plug in to get improved analytics and experimentation feedback loops when working on developing your models. We didn't see a lot of sense in enterprises going to 3 different organizations and signing 3 different contracts in order to set up a single MLOps pipeline. So we decided to tackle this problem last year by launching Lightning AI Studios, which is our answer and what we consider to be the end-to-end solution for MLOps. And I'll go into this firsthand in just a second. So, switching over to give a bit of a demo here. This is a team space, which is really just a collection of programming environments, data, and jobs that exists on the cloud. I can start a studio right here, and what we're going to do together, because this is an LLM-focused talk, we're going to go from no coding environment to actually deploying an external LLM in about 5 minutes. So, this is going to launch up, and while this launches, I'll highlight a few things. Studios are shareable. You can start a live studio session, or you can share studio access with anybody who's invited to your team space. So if you have an organization, that organization can be broken into teams. You can give anybody on your team access to launch your code, or on a coding environment by coding environment basis, create separation here. Or if you need somebody's help debugging in real time, just start a live session and send them the link. We have a number of plugins on this side which simplify a lot of the tasks that we as ML operators need to do. And I'll zoom in because I can see people squinting. But over here, we have the VS Code plugin, which is what you're seeing, but you can easily switch to Jupyter Notebook if you as an operator prefer to code in that. And then for switching to GPUs, you can pop over to here and quickly see the selection GPUs that you can get in real time and the wait times that are updated based on availability. You can see A100s and H100s are hard to get today. But having launched this studio and having it fully up and running, I'm going to launch a web terminal, which you can also do in browser, but I'm going to launch one here so that we can see. And I'm going to use the LitGPT library that I went over during my overview of the open source libraries a few minutes ago. So I'm going to run this installation. And what this is going to do is it's going to install our LitGPT library, our LitServe library, which LitGPT is built around. And it's also going to install Hugging Face hubs that we can grab an open source model to serve off of there. So this will run and should just take a second. And while it does, I'm going to grab the next command. Cool. So now we have installed all of our libraries here, and something that is great about these studios is that the environment is fully persistent. Once you set it up, you can switch between GPUs, you can spin up to multiple machines. You never need to reinstall libraries. So I'm going to go ahead and jump over to a 1/L4 at the moment. And this change specifically, like making the conda-env persistent and the apt-env persistent, allows for a paradigm shift in how we operate, because a lot of times organizations will negotiate with AWS or GCP or Azure, and they will have to make these reservations that are days or weeks at a time, and then there's always a scramble when your machines become available to get your model running on that machine as quick as possible. That doesn't exist with Lightning Studios anymore, because you have the ability to develop your model on a CPU, scale up to what you would consider a testing machine, and then scale up to the actual number of machines you need for your production case when you need to. So the L4 is ready. I'll jump onto here. And it'll just take a second to start up. So now that we're up, I'm going to go ahead and just call litGPT serve Microsoft Phi 2. This is going to pull the Phi 2 model off of Hugging Face, and it's going to immediately start serving it on a local port, which is great for a starting use case. But if you're thinking about using Lightning or another provider to do your development, you want to make going from a production-ready model to deployment as quick as possible. And so that is something that we're really focused hard on at Lightning, and for that purpose, you can turn AnyStudio into a service. So if you look back at our plugins over here, we have the plugin library where you can install more plugins or request plugins that you might not have access to, and we have the API builder. So I could drop that in here, and it'll take a second to install. And using the API builder, you can see this is now running on port 8000. I can hop into here, create a new API. We can call this serve Phi 2. Running on port 8000, I could add tokenized or basic auth if I wanted to. I could also give it a custom domain and serve this on my site. Or I could add an auto start, meaning that I don't need to keep this studio running. I could tell it, like, hey, run litGPT serve Microsoft Phi 2, or litGPT serve my custom model, which is currently stored in the studio or stored elsewhere in my cloud. And when this studio receives a request, when this API receives a request, it will start up the studio. For the time being, because I'm demoing this very temporally, I'm just going to not enable auto start. But I create an API, and now we have an external link. So if I take this request here, and I'll go into another terminal. I'll drop that there. I could use this link to hit our endpoint, and did I leave a double quote somewhere? Hold on, my apologies. Let me try that one more time. There's the local. Okay, one more try at this, because I can't see where I put the double quote. Oh, I see it's missing it from the front. All right, never mind then. I can't get the curl command working properly. demo issues, but what we have right now that would be working if I could properly type on this CLI is an externalized LLM in about 5 minutes, which is great for a short demo, but if you're using this for a production use case, you don't want to just serve an open source model. You, at the very least, want to do some RAG, and more than likely, you want to fine-tune or pre-train on some large amount of proprietary data that you have for some use case that your firm needs you to. So for that, we really need 2 more pieces of the puzzle. We need the ability to bring in a lot of data to this equation and run a fine-tuning or pre-training, and we also need the ability to distribute this easily across multiple machines to develop our model. So I'm going to talk about the latter first, and while that's getting started up, we'll go over the data portion. But to do MMT with Lightning AI, you just need to install the MMT plugin. And for the purpose of a quick demo, I'll just drop in a transformer model into my existing cloud space. Great. So once you've installed a template, or if you have your own model, given it the model, what you can do is go to the MMT template, hit New Run, select the entry point for your model, or give it a custom command. And through the custom commands, we can run much more complex pipelines that can split really long-running jobs into smaller chunks that can be executed quickly. And we can select any number of machines. For this one, I'll just do about 8 machines, but we have tested this up into the significant 5 figures with the number of GPU cores and about 5,000 individual nodes before. So we can handle those larger jobs that you may have. Now this gets started up, we'll talk about the data side of things. So if I go back to my team space, you'll see this tab drive. This tab drive is where all of your studio memory, all of your S3 connections, Snowflake connections, and uploads are stored for your team space. And it's separated by team space, but this is updated in real time. So if I add a data connection, and for the purposes here, I'm just going to add a public one, but you can add private ones as well, and it'll walk you through connecting them. If I add a data connection, you'll see in a few moments it becomes available in the drive itself, but this is also available. It was actually copied to my clipboard, the command to navigate there. This is also available in my studio. So I can navigate straight to this S3 bucket and see the files that are there. And so what we've done here is we've created a framework where you can push your data into your S3 buckets or Azure buckets or GCP buckets, and using a library like LitData, which is built for streaming and chunking, if you are doing a larger fine-tuning or training across hundreds or thousands of GPUs, you could stream that data directly from your cloud bucket into your model where that data is needed. So we'll go check on our model right now, which says it's running, and we'll see, is it actually running or is it just in setup? It's still in setup, but from here, we're going to give you the ability to monitor all of your machines. On the CPU side, if you're doing like a trial run, you'll be able to see utilization, RAM, and disk. But on the GPU side, we really focus on utilization, temperature, and power as well, so that if there is a machine malfunctioning, you might be able to identify that and respond to that quickly. And once the model is actually in the execution phase, you'll be able to stream logs here, as well as SSH directly onto the machine to debug if there is any issue running your model. We'll give it about 10 seconds before I want to jump back and talk about a real life example, because we're running a little short on time. Okay, another day, I'll show you all the result of the MMT. But, so in the last 10 to 12 minutes, we have launched a persistent code programming environment, deployed an open source LLM, and exposed that open source LLM to the internet. We've also shown you how you could use our drive system and our data ingress system to bring in data to fine-tune or train your larger models, as well as how you easily have plugins available to scale up to hundreds or thousands of GPUs. But as referenced, this isn't, deploying an open source model is not the problem you need to solve. The problem you need to solve probably looks something like this. Your firm has valuable market data, and you need to evaluate various models to fine-tune, pre-train, various methods that whoever's giving you these commands doesn't really care about. They want to see a chatbot. They want to be able to talk to that data. So looking at this from a naive perspective, you could think, oh, okay, we'll just use Llama 3 or Phi 3, and everything will go great on the first try. But it doesn't take long to really realize that there's a ton that can go wrong with productionizing these systems. If you're sitting through this, you probably already know that. And none of you want your company to be the next company with one of these headlines related to a bot that doesn't work. And to do this right, there are a ton of questions that need to be answered. So what we need to consider is, how do we set up a systematic, experimental, quantitative system that reduces the risk here? Because there's too many questions to just take a guess and hope it works. You're going to end up like this. So what we need to do here is build a chatbot. It can be RAG, fine-tuning, pre-training, with a RAGOS evaluation pipeline. And to do this, the stack that we propose is doing it on Lightning Studios, serving it using litserv, and then using the RAGOS Python library to evaluate, doing some logging and aggregation with Comet ML, which I don't think will be necessary long in the future because of some other stuff we're doing in open source, but then visualizing with LitLogger. It creates a really nice experience that I'll walk you through. So some major concepts and considerations. RAGOS is what we call an LLM as a judge framework. So it uses one LLM to judge the performance of another. There's a standardization called GeoVal, which was written about last year, which uses GPT-4 as the judge. This can be very expensive. It's often cost beneficial to do either your own fine-tuning to develop your own judge, or to develop multiple variations of your own judge, and then run iterative sequences effectively, testing all of your potential models across all potential judges to assess. So in the assumption that we're not going to use GPT-4 because we don't want to give OpenAI our money, what model provides the best critique and the best judge? And the other thing to consider is, how can we avoid bias in our decision? So this is where things get a little bit hairy, because this type of evaluation takes a long time, which is why people tend to cut corners. RAGOS does not distribute well across multi-core GPUs. So if you try to go up to like the HA100 or 8H100, you're going to run into issues with the library itself, and it needs to be expanded to do that. So your best bet is using single core GPUs and distributing across many of them. But this takes a long time. Using Llama 3 for synthesis and as the judge, it takes about 2 minutes for both a single suite evaluation and for a single question evaluation. And so if we're developing a model where you have a 10,000 question universe, that would take about 330 hours or 2 weeks to generate. If you're going to do some type of Monte Carlo style iterative evaluation to remove bias from a single test run, you might want to do 10 evaluation suites per model of 5,000, so non-mutually exclusive questions. And so you're looking at about 1,600 hours per model, and this adds up really, really quick. If we draw an enterprise scale problem out of this, where you have 12 potential LLMs you're evaluating, 12 different fine-tuned or pre-trained variations, and 4 potential judges, you're talking about close to 77,000 hours of compute and more than $115,000. So how can we actually solve this problem knowing what we know? Well, in a matrix where the LLM is the LLM to evaluates X and the judge is Y, we can kind of consider this as a matrix space. So you have the LLM to evaluate the judge, and then the question to evaluate along the Z-axis. And using the Lightning SDK, which can interact with studios and jobs, we can slice along that Z-axis so that we can actually have multiple jobs spin up, each taking one judge, one LLM to evaluate, and 1,000 questions at a time, getting the runtime down to just about a day on each of those jobs. So, I'm going to skip the live because I'm running out of time here. But effectively, with Lightning AI, you can save about 20% of the cost, and we could actually parallelize this down to be run in about 3 days' time on our framework. And so, takeaways, you can develop cheaply on CPU using Lightning Studios, begin pre-training, fine-tuning, and deploying in minutes. And if you have those enterprise-scale jobs, we would love to talk to you about how we could parallelize those down and help you get your results quicker. That's all. Thank you so much. How are we on time? I can take questions here, I can take them outside. We have some time? Okay, the timer says negative, so I wanted to check. Yeah, if anyone has questions, then I can answer them. Don't be shy. I'll also be at the booth all day for Lightning AI as well if you want a little bit more of a hands-on demo. Yeah. Yeah, so with the evaluation part, what we can do, and my apologies. I was busy today. I forgot to find where this is. So with the evaluation part, what you can do is you can, okay, start this up. Instead of using a file as the entry point, you can set like a bash script as the file or just drop the bash code into there and effectively have a matrix of like, okay, here are the LLM models, the judge models that I've maybe pushed to Hugging Face or somewhere else on my cloud I want to pull down, and have those pulled from that matrix as input parameters. The input parameters that you're giving to your test and evaluate script is going to be judge model, LLM model, and then slice, so like 0 to 1,000 or 1,000 to 2,000. And then that will pull down those specific models, those questions, run just that evaluation, and then spit you out, if you log it the way that I did here using one of our open source libraries, LitLogger, it will spit you out into the studio some really nice charts from every run that you'll be able to evaluate to see, you know, the answer similarity, the response time, because maybe a model performs really well, but it takes twice as long to respond. So those might be considerations that you have in the production space. Are we good? Yeah, cool. I think the... How do I turn this off? There we go. Yeah. Thank you all.